for the introduction. This is you've introduced the name of the talk already. You can see the iconography of the new sidewalk, which includes dining on the sidewalk. Of course, not today, not in Toronto because of the snow, but nonetheless, we're going to see a lot of changes that we'll be talking about at the sidewalk while I'm speaking. I'm going to talk about three issues. I'm going to focus on why the sidewalk delivery robot and other related robots are likely to become more pervasive before robotaxis do. I'm going to talk about the planning and governance issues as that change occurs, and I want to talk about how an ISO standard can address these issues, which is the key core work, is the standard from ISO, which I'll be describing and talking about as well. That's the name of the standard on the left. It is intended to address goods delivery, passenger drop-off, robots, crowded sidewalks of all sorts of competitive issues, and also, again, goods delivery is an important and critical part of that. So we're going to be focusing down on the center issue today, that issue of sidewalk drones, but the entire scope of those issues are all incorporated within the standard that I'll be talking about. Its name is 4448, ISO 4448. And if you think about the sidewalk and curb that we know now, it's mostly in the past. Go back a decade or more, it was really for bus stops, taxis, and parking your car. Over the past decade, we've introduced finally more cycling lanes in more cities. Bike shares are new over the past decade or so, ride hailing, e-commerce, and so on. So more and more as we've moved out, of course, just most recently because of the pandemic, alfresco dining has joined the sidewalk, and we're now expecting delivery bots and other robots to sweep and clean and maintain the sidewalk and so forth are on their way. They're under development. They're being used in a few places in pilots and so on. But that on the right, everything circled in red, is the subset that I'll be looking at today. Keep in mind that all of this is about governance, regulation, and operation of these vehicles in those spaces. Briefly, what's been changing, what has started to change, and what will increasingly change is the structure of urban revenue, because if we're parking less, or if we're paying fewer fines because of automated vehicles, for talking about robotaxis in this case, if there's fewer traffic fines because of automation and so forth, this all impacts urban revenue. Electrification impacts provincial revenue as well, because of fuel taxes and so on. Sharing changes the nature of congestion. So there's congestion at the curb for loading and unloading passengers, and congestion around bicycle lanes and so forth, which has been growing. But it also, of course, sharing requires us to change infrastructure. You'll see bike docks and scooter docks and so forth, all those kinds of things. E-commerce changes congestion as well. Again, we're loading, unloading at the curb, and we're expecting soon automation at the sidewalk would change that. We'll come back to that toward the end. We'll see more of that. So the vehicles that I'm talking about come in many sizes and shapes. You can see the slowest one on this is up in the top here. The slowest one only goes actually less than walking speed. It's slower than a person walking. The fastest one is sort of at 56 kilometers per hour. Some of these on the very far right, and this one in the bottom center, these are faster, larger vehicles that are meant for bicycle lane or actually the roadway itself, to deliver whatever they're going to deliver. It doesn't matter what they're delivering. What it matters is that these vehicles are invading the sidewalk space, bicycle space, roadway space, and so forth. And we don't have rules about these. These will largely be unaccompanied by a human. You'll see there will be teleoperated, but that's a different issue. Here's one of the smaller ones, one of the more popular ones from a company called Starship. You can see the size of it is quite small here. It weighs less than 25 kilograms. It's something that a person can readily pick up. It's only carrying 10 kilograms, like a large bag of potatoes or a couple bags of groceries. So it's really for a single personal order. It's not meant for massive goods movement, but it's kind of designed and scaled for a campus use. There's many of them under development. On the left is one from San Francisco. The one in the center operates here in the city of Toronto. I don't know, they only have a couple of them in this company called Tiny Mile. This actually on its way to deliver something. It's not purely a pilot as in an experiment. It's actually been put together by a couple of people, one of them ex-Uber, and is being used to deliver lunches and food from some of the vendors in the area. It doesn't go very far. It just goes, it's sort of in a kilometer radius kind of thing. And on the right, of course, that's purely an experimental vehicle, ambulatory. We'll come back to those. So these are all the kinds of things under development. I want to underscore that right now, all of these vehicles are teleoperated. So this is from a company called Postmates, which was, by the way, last week just purchased for $2.65 billion by Uber. It's a delivery company that is mostly delivering things like Uber Eats kind of business. However, it also developed a robot, and the video showing this robot shows this robot creeping up toward this static barrier on the sidewalk, and it drove around it rather neatly. Well, that's because it's being teleoperated the same way a young child would operate a car on the living room floor with their little radio control system. So these are currently teleoperated. Here's where it's going. It's going to a place where this single operator can operate 2 or 3 of these vehicles at once by having all of these things on screen and just paying attention to the one that needs his help at any one moment. In the future, it's expected that one person could operate 20 or 30 of these at once. And that's because more and more the machines do more and more on their own. They only need to be helped out when they're in trouble. And so you can imagine an operations center with, say, 10 operators and many dozens of screens and many hundreds of vehicles being operated by shared, swapped, and shared back and forth by these operators. And so that's where that technology is on the cusp of now. So I'm going to talk a little bit about why sidewalk delivery robots, that's what's next. This is coming before robotaxis, and I'm saying these next few comments because we're going to be caught out by surprise the same way we were caught out by surprise by ride hailing and by scooters and so on. We're not prepared for this, and that's the remainder of my talk. But the next few slides are why is it that this is going to come first? The major fundamental issue is that the barriers to deployment are far lower for these robots than they are for robotaxis, and the accelerators for deployment are far higher. And so briefly, the first one is that safety. These are slow, small, so the momentum of these is so low that it would be, especially the first one I showed you, would be very likely to harm a human, or excuse me, and very likely to cause serious harm to a human. I'm not saying something couldn't go wrong. Of course, it's possible that it would be a tripping hazard, for example. However, it's a much lower, it's perceived, and in fact, because of momentum, a much lower crash hazard than a robotaxi would be perceived to be. There's also no human passengers, and that's a mixed blessing, but it turns out that that's another reason that it would be less dangerous, and it is perceived as less dangerous. It's really the perception that matters. So very quickly, the fear barriers. Many people that are afraid to say that they're afraid to take a robotaxi, or say that they're afraid to be around them. They're afraid to cross the street if they were there and so forth. That fear doesn't exist for these small bots. Maybe it should, but it doesn't at this point. Concern for job loss is lower. It's not zero, but it's lower than it is for robotaxis and self-driving trucks, for example. The cost to develop them, I showed you a few slides back, that little pink one in the middle, that was done by 2 guys out of a garage. There's no big multi-billion-dollar anything to do those things. The very first one I showed you from Starship was developed by the people that developed Skype. So they have a lot of money behind them. But nonetheless, the cost barrier to get started and try it out is quite low. The regulatory barrier is lower. It's not zero, but lower. Infrastructure is complicated. The infrastructure barrier, they would say, is everybody who automates says the infrastructure is not an issue. That's an exaggeration. Infrastructure is an issue. And depending on the nature of your sidewalks and what you want to do there and how many vehicles you want to use on it, infrastructure could indeed be a barrier. I will show examples of that in a little bit. But the other issues here are reduce comparatively the barrier for these robo-taxis. Let's just look at the number 8 in the bottom. The fact that we have been promised and have not been delivered this concept of full autonomy. In other words, the promise of a robo-taxi that will take you anywhere you want, anytime at all, is not nearly fulfilled. Even though they're becoming available now, they are not available in the sense of taking you anywhere. They're in highly constrained areas. In fact, if you live in almost any city in the world, there's 0 of them. They're only in a couple of cities now. So they're very limited, and they're limited because you, number one, don't want to rely on them unless it takes you anywhere you want to go. In other words, you would not give up your personal vehicle for a robo-taxi until that robo-taxi can go everywhere, and it's far, far from going everywhere. And you're not going to buy one of these fully autonomous vehicles. They're not available in spite of Tesla's promises. That's a false promise. They're not only not available, but even if you were to get a level 4 vehicle or a vehicle that's highly autonomous, it doesn't take you everywhere, so you wouldn't want to own it. That myth is holding back robotic vehicles, robotic taxis, but it doesn't matter to these bots at all. The fact that you can get your lunch delivered to you, or that the person making your lunch can deliver it to you using these bots, the fact that they're teleoperated doesn't matter to you in the least. You get your lunch, he made his delivery, that's all that matters. So that the matter of full autonomy does not hold us up. Just the last point, the robotic sidewalk robots, small robots, are so versatile, and so many of the things they're on the verge of doing that it provides more opportunity to exploit, more opportunity for investment, and so forth. So the total overall picture is that the risk and the reward equation for the sidewalk robot is so much more favorable to these robots than it is to robo-taxis. The barrier for entry and the barrier to profit and the barrier to development is all lower. And that is the summary of the argument that I make, that we will see these robots before we see robo-taxis in a pervasive manner. Just a week or so ago, a couple of days ago, the state of Pennsylvania legalized autonomous delivery bots, and there's a problem. It's good news that they legalize them, and it opens the door to innovation. It's a problem for each city because they permit them. They just said they can be up to 550 pounds, which is huge. It's a refrigerator-sized monster. It's one of the biggest ones that I showed you back in an earlier slide, allowing them to go at 15 miles per hour, 19 kilometers per hour. In Florida, that speed is set to be 24 kilometers per hour. Absolutely absurd speeds for a sidewalk. So if you look at the bottom comment here, there's a mobility director in Pittsburgh says, well, in light of this, we need to work on some local control because there's no way that it would be sensible, safe, or reasonable to permit larger, faster devices such as this on the sidewalk. It's questionable to some people whether any of them should be on the sidewalk. San Francisco said no to them completely, and then reneged and decided to try them out because there's a huge amount of value to this technology, and there's a huge amount of risk in terms of safety if they're too big and if they're not organized in an appropriate way. So I think Pennsylvania has helped wake people up, but I think the cities are going to have to scramble to make sure that the environments are safe and sensible. So let's look at some of those environments very quickly. What are some of the planning issues that these machines will disrupt? I'm going to go through very quickly through a series of slides that are, I'm looking at them mostly for the imaging. They've come out of a book that we're writing, so don't worry about all the text, just consider each of these images. This is an image that is indicating to me, the purpose of the image is to compare a human delivery and a robotic delivery. That's why it's an advertisement for this company that has the robot. However, consider distracted walkers being disturbed by or possibly tripped by or possibly running into these devices. So there's a pedestrian hazard. There's the issue of narrow passageways. How would this robot get past a a person on a wheelchair, for example, in this circumstance. This is a difficult circumstance, photographed to make the point. All these photographs are my own, by the way, just here in the city that I'm in Toronto. And it's very, very easy to find circumstances where robots would have difficulties. This is a transit, the bus stop. The bus comes here about every 10 minutes during the busiest parts of the day. And this is very often has, of course, not now, right now during COVID, this is empty. But usually this was a very busy intersection. The central picture is the same intersection. And how do bots get around these places and so forth. The person on the left here has a disorder called kyphosis, so she's hunched over and cannot look up to see what's coming. So if a bot not understanding her condition came in and perhaps startled her or blew its horn or it whistled to startle her and so forth, be very inappropriate. So there's a kind of a nuisance factor or a risk factor in that left. Again, if you look at this older people on the right, in front of them is a much narrower sidewalk. Where they are now is quite wide, but in a few moments they're going to be in this much narrower space. What does the robot do? We don't want to disturb people who are on the pedestrians on the sidewalk. So what rules of engagement are needed to take care of situations like this? Here's a here's a sidewalk with a piece of infrastructure that the robot would either have to stop for, which would hold up the pedestrian behind it, or it would have to go around in a rather sudden, possibly sudden move, which might startle the pedestrian coming toward that robot. And what if that pedestrian wasn't really paying that much attention? Could it cause a mishap and so forth? All kinds of clutter issues on the street. On the right, there's another piece of clutter. What do we do about garbage day? Do we change the rules of garbage collection, or do we say you cannot use these streets during garbage collection days? Or how do you tell the robotic companies, here's the schedule for the garbage collection, do not use these streets on those days, for example? Whatever, I'm not saying what the answer should be, I'm only pointing out problems that need to be addressed, and that's the standard addresses all these problems with its data and its procedural rules that get decided by a municipality. The rules are always elective, of course, but here on the left, you have a sidewalk in rough shape, and a construction party has just simply left the gate open. You can see that on the left. On the right, there's a place with no sidewalk. So do we deny these people the ability to get deliveries using these, or do we say, okay, the robots can go on the street, for example? Certainly they could, technically, but what rules do we want to have? What about our parking rules? All kinds of people park in all kinds of ways, straddle the sidewalk. This truck is a pretty egregious example, but moving trucks will do this a lot. What happens then? How is that information broadcast to the company that sets out a drone, and now the drone is trapped, or sorry, a robot, and the robot is now trapped. It can't get through, or it's not permitted to go on the road and so forth. How do you handle those circumstances? On the right is a city vehicle on the right parked on the sidewalk, and the space between that vehicle and that hedge is too narrow for a wheelchair. I was there, I took this picture, I measured that, and that city vehicle would have blocked access to somebody in a wheelchair. I was in this streetcar on the left, and the FedEx truck made it didn't prevent me from exiting the streetcar, but it blocked my way leaving the street. I had to walk around the truck. When I came around the other side of the truck in the center, I noticed the truck was standing in a no standing area. Well, because there is no place for these trucks there's no facility for the truck to park. So it parks in no standing very, very frequently. That's their solution. And if you look a little bit to the right, it's the same picture on the right-hand side. It's connected to the picture on the left. That sidewalk was too busy for robots anyway. So if you were to argue facetiously, or I think incorrectly, that, oh, we should replace these trucks with these robots, wherever the trucks can't find a place, well, the robots will be possibly likely not to find a place. And you just shifted the problem from the no standing zone over to the parking lot anyway. Here's an example of a similar sized vehicle in New York. This vehicle is manipulating, what would you say, 25 or 30 boxes. Well, that would take, I mean, those tiny zones would take bots would take 30 of them. If you had a bot the size of the picture on the right, maybe you could do it in 15 or 12 of them or something. This is like the bus argument where you say one bus takes the place of 40 cars. Well, in this case, one truck is taking the place of 30 bots. So there's quite a debate which way to go here. We run the risk of simply moving congestion from one place to another because of the way we do things, and just trying to solve this thing that you see on the left with the thing I was showing you in the few previous slides. Let's take a moment and think about that. Here are some streets all in Toronto. One of the things, if you look on the left, the shopkeepers like to put signs out that these create obstructions. I just got off the phone where somebody said that it's very easy to trap a robot. This is a person that works for Bosch, works in hospitals, and it's very, very easy to trap a robot behind things that he's not allowed to go by. He can't go backwards because there's something now behind him that he can't go around and so forth. So that's the issue of trapping robots is difficult. If you look on the right side here, this is a place where a robot could easily get trapped because it can't go out on the road and it can't get past these people. And if it did get, as it waits for these people to go on, there's a very narrow passage up in front between the planter and the clothing from the shopkeeper and so on. There's all kinds of problems like that. What happens? Do we need other robots to keep the sidewalk clear so that the robots that are delivering your sandwich can actually find their way amongst the leaves or amongst the snow? How do we handle these circumstances? And just to say, we'll find a way to automate our way through these things. Yeah, that's possible. Do we want to? Remember, there's also pedestrians and people walking pets and wheelchairs in all these environments as well. So how can an ISO standard address some of these issues? So here's an instance. This is, again, one of the companies I showed you earlier. How many of these ought to be permitted on a single block face at once? You can see 4 vehicles in this picture. 2 of them are in this block face that were from our perspective, and there's 2 more on the other block face. You might think it's just fine to have 2 or 3 or 1, but how would you be with 40 of them? And what's to stop that from happening? So imagine, and again, we're talking about what the standard looks at. Imagine having a limit over time during a dynamic limit. So at some time of the day, we allow none. At some other times of the day, we allow 3 or 6 or whatever those numbers are. And what happens? How does a robot behave when it finds it can't pass through? How long does it have to wait? How far does it have to pull over? How much does it have to stay away from out of the way of pedestrians in this case? Or if there's pedestrians that are stopped and they're doing something, it doesn't matter what they're doing, but the pedestrians are occupied with something. How much this robot behave, and when should it time out and go the other way around the block? When does it stop? When does it give up? Maybe these are workers doing something. Maybe there is no way around. The robot would not be able to tell that and so forth. So what are all those rules and so on? What should a robot do when it comes there's a crowd of people? So should it just queue in behind and become one of the pedestrians and get across the street? Pennsylvania, just as I showed you earlier, said that robots are classified as pedestrians. I think that's a mistake, but that's what they did. Here's a person, it's a pedestrian. She happens to be paraplegic, and she was at an intersection like this, waiting to go across the sidewalk when a delivery bot was crossing the street. She was waiting for the light to change. The robot was waiting for the light, for a fresh light, but she was coming across from the opposite side, but she couldn't mount the curb because this device was standing on the sloped area where she would bring her wheelchair up, and she couldn't get around the device. You might ask, if the device was teleoperated, why didn't it back up? It's a very easy answer to that, is because any teleoperated person needs a brake, came to the intersection, parked the device. He had 12 or 15 seconds to refresh his coffee, walked away from the screen. When he came back, the problem had already been in mid-problem, and she was stranded, reported to the newspaper, and it shut down this operation for a while until they sorted out their procedures. How many bots should crowd together in a single place? Again, we saw this issue of how many will we allow on a block face. And I don't say this facetiously. This is a photograph from one of the companies, and it's a very real concept. The idea is that there's a lunchroom, and it's delivering all of these lunches, and it leaves the lunch restaurant, and it goes off. And of course, these would all split up and go their own way. That's why they're all in separate vehicles instead of being in one truck, because they're all going to go to a different destination. But at some points, as they travel, they would be possibly together. And what do they do when they come to the intersection? Well, they block, how do they organize themselves at an intersection? What are the rules so that people can get around them and so forth? All kinds of rules are possible. And you can see that every rule has a limitation. There's just only so much you can do. So how do you set those rules? Different from street to street, from sidewalk to sidewalk. Highly dynamic problem that needs to be solved. How do you do that? And after you do all of that over the next 3 or 5 or 9 years, the value of a wheeled robot is limited because of curbs and sidewalks and steps and so forth. Ambulatory robots are almost certain to play a larger role as time goes on. I'm talking about local personal deliveries. I'm not talking about large goods movements. The idea here is that a vehicle that holds 4 or 6 robots and has lots of goods in it, that vehicle then goes somewhere and ejects 3 or 5 robots to go about its, let's say, kilometer radius or half-kilometer radius to deliver its goods and so forth. Very interesting ideas, lots of barriers to this. What about snow plows? Many people developing snow plows. This is a robot that is for inspection, sidewalk inspection. And that's what it does during the summer. And during the winter, that same robot plows snows. You talk about versatility. It's very interesting. And you can see the operator, the fellow back in the red vest, is the teleoperator of that vehicle. That's the same person that operates these. He's just not in the picture, because we would like you to believe that they're autonomous in the sense that there's no humans around, but there are humans around, and they are watching and guiding. This is line of sight. I'm going to talk in a minute about line of sight and non-line of sight. This is line of sight teleoperation. The very earlier one I saw, where I showed you where the person was at a desk, he was distant. That's a non-line of sight teleoperation. So here's the point. Whether the teleoperator or autonomous, it doesn't matter. It doesn't matter what they're doing, delivering or sweeping or cleaning or inspecting. It doesn't matter whether they're on the sidewalk or a bicycle path or in the road. It doesn't matter whether they have wheels or feet. These things are here, they're starting. And because they're teleoperated, we don't need to wait for any new AI. We want that AI to lower the cost of operating them, but that doesn't prevent them from being operated. And one of the first bots that I showed you is already making deliveries for $2. I suppose that's break even because they're looking for business, or it might even be a minor loss, but it's still already less expensive than bicycle couriers, for example. So what does ISO 448 claim to do? It claims to manage all sorts of things like sizes, weights, and speeds. And it doesn't constrain them. What it provides is the language for a vehicle to say, here is my size, weight, and speed, and the language for a city to say, here is the size, weight, and speeds that we permit on this geography or this street, and so forth. So in other words, it's the data specifications that allow governance to be in the cloud so that a fleet operator can ask the cloud, I need to send a robot from this place to this place. Therefore, I need to cross these four. Block faces in order to get to where I want to get to. I need to reserve permission to go on those spaces. Is there room for me? Well, because one of them already has one of them only permits two robots, and right now it's occupied. There's somebody there. You have to wait until. And if you send out a delivery and you don't have all of that lined up, then you find your bot has to wait. So now you're going to be cluttering the sidewalk with a robot waiting for permission to get to the next block and so on. So it becomes, I think you can appreciate, quite a mess, but it's computable, it's solvable. It just takes care to create the data requirements for it and the procedures and protocol to do all of these things, and all the rules. I mentioned sound and lights for accessibility issues. What are the rights of way issues? And it may be at some point, some of these vehicles may be carrying hazardous goods. It's possible. I'm not suggesting it's a good idea, but if it ever happens, there needs to be signage and signaling on these vehicles to handle this. So what are all the standards for all of those things? So now that you've heard all of this, I hope you're getting nervous and upset because this is not a nice and easy problem. It's going to make scooters look easy, and they weren't. But so I'm asking you, consider which job is harder. Is it harder to invent all of these clever vehicles in their AI, or is it harder to manage them in our cities? I think you know what my answer is. You hear what they claim and what they show they're able to do in the videos, but what do we in the city want them to do? Is our infrastructure ready for this? Can we absorb these things? How many of them can we absorb? Do we have the regulations and systems in place to manage? The answer to all of this, of course, is no, which is why San Francisco said no. It's why Washington, D.C. has had problems with them. They're exactly the same thing. They know they're important, they know they're useful, but they're very leery of it. Here's a piece of good news. If we want to go this way, if we want to permit some places to have improved pedestrian clearways, that part of the sidewalk where we walk on now, where it's clear sailing for pedestrians. If we want to improve those clearways, widen them, make them easier to navigate and so forth, in order for robots to operate, then we would also improve the experience for wheelchair users. So it's a possibility for a win-win here, possible. But we need to really look out and think this way in order to make that happen. However, in my opinion, if you simply add robots to pedestrian clearways as they are, I showed you many examples, we just put robots in those places, I think we're going to make them worse for everybody. We're going to make them worse for you walking your dog, and we're going to make it worse for you if you're using a wheelchair. So I think we have a possible win, and we have a possible risk there as well. Okay, I just have a couple more slides left. I want to show you some very critical work called maturity models. So here are the questions. Imagine a municipality says, or someone says, a business district says, what level of automation can we permit at this particular block face where I operate, where my customers are, where I am, or maybe a certain downtown area? What ought we to be able to permit here? The second question is, we really want to permit a certain kind of automation. We really want to have teleoperated, non-line of sight vehicles that come here to support our business and to do our deliveries. And so we asking the city to invest. So what does the city have to do given a certain level of desired automation? They're just the same question asked in reverse. This is the as is question or I'm ready to invest question. So what we've done is we've defined a set of classes of blocks, so classes of capability of the sidewalk, and what capabilities does that sidewalk have to have, and what features does it have to have in order to permit a certain level of automation. And so given that, we can define the readiness of each block face, or we can say, here's what you need to do to this block face to upgrade to the readiness that you would like to have. I also want to point out that the Kerb, that's the European spelling, by the way, if you're used to CURB, the Kerb and the sidewalk are assessed independently. And the reason is, you may have a Kerb where they say, we want to have automated taxis and we want to have automated goods trucks, but the sidewalk, we're not concerned about that. We're not going to permit sidewalk robots. Or conversely, you can have multiple block faces where so we're permitting sidewalk bots here, but we're not permitting robo-taxis yet. So that's why they're assessed independently. What's the purpose of the models? It's for governance, regulation, maintenance, enforcement, and so forth. So I'll just show you one of them. This is a little tiny piece of one of them. There's the maturity model has 6 columns. The class 0 through class 5 columns. Any of you that are familiar with SAE level 5 levels, 6 levels of automated vehicles, it's parallel to that, but it's not the same thing. It's not describing the technology. It's describing the kind of technology that the sidewalk can admit. So in other words, let's look at class 2. What's permitted in a class 2 sidewalk? Well, we're permitting line of sight teleoperation. So remember the fellow that was operating the snowplow? That he would be permitted to operate that snowplow on a class 2 sidewalk. But he could not be permitted to operate on a class 1 sidewalk. In other words, He could plow the snow on that sidewalk, but his hands would have to be on the machine. He would have to be operating a snowblower as he would do now on a class 1 sidewalk. But a class 2, he can teleoperate. On class 3, he could operate that snowplow from a building in another country. It doesn't matter. It's just non-line of sight, for example. And so each one of these classes has a different level of permission, a different level of signs and signals. When you talk about signs and signals, like the robot's not reading the signs, but other humans that are permitted, pedestrians are on this side. Pedestrians need to know what's permitted here, what's going on. Why is that snowplow operating on its own? And what are the cautions that I need to take, given that I'm going to still walk my dog on that same street that there's somebody plowing the snow and so forth. I need to understand what those are for my own safety. So what has to be signed in that case? Here's a couple more rows. Remember, there's about 25 or 30 rows in this model altogether. These are just the rows for defining what does it mean to fail. What is a failure on a class 3 sidewalk? So a class 3 sidewalk, it's failure. There might be, if you have to go back because it's stacked up here, so you see previous. So maybe there may be a pedestrian or an ADA complaint. So that's a possible failure. It may be that an enforcement officer observes something and reports a vehicle that's another kind of failure. So in other words, maybe there's a fully autonomous vehicle in a class that's not permitted to be on that, for instance. It's also possible that you see a robot without an operator because it doesn't have to have one because it's teleoperated, but it's stuck and it's somehow broken down. So that's a failure. What happens during a failure? In other words, there may be failures that require an enforcement officer to arrest the vehicle. It's possible if something has gone wrong. It may be the case that under certain circumstances, the vehicle must be broken into to see what its contents are. The same thing as when you're pulled over for drunk driving, we can inspect your trunk. If you arrest a robot for whatever purposes and want to inspect it, then you need to have access to it. How do you do that? Or what are you permitted to do to gain access to that? And so what are the standards for that? So these are all the kinds of things that need to be worked out before a city can say, come on in with these devices. That's why I think the state of Pennsylvania was premature. I'm glad they did what they did. I mean, it's horrifying that they did what they did because they haven't considered any of these readiness concerns. I want to talk about there's 4 more slides, a couple of very important issues. One is that I mentioned earlier, we're going to be losing a lot of monetizable activities, parking and ticketing and so forth. That's an important source of revenue for cities to manage and governments and states and provinces to manage transportation. We will need to monetize all of these devices and robots and uses of our public space. A standard, the ISO 4448, that standard enables us to manage large numbers of vehicles from multiple operators and large numbers of robots, of course, as well. Such standards enable regulation and management. That's the whole purpose for the standard. If you can regulate and manage in a digitalized fashion, that automatically or that naturally enables metering of large numbers of vehicles because you know where they are, when they are, how big they are, what they're doing. Not what they're doing isn't as important as where they're doing it and what time of day they're doing it and so forth, so that we can enable location-based, time-based micro-processing, for example, micro-pricing, for example. And if you can do that, and you can operate large numbers of machines, that would enable significant revenue, which allows us to manage larger and larger fleets. I'm talking about cities. When I talk about management, I'm talking about governance. I'm not talking about an operator worrying about the vehicles that he owns, but I'm talking about the city managing the access to these fleets in the city. So the standard enables monetization. It doesn't cause monetization. It doesn't say what monetization should be, but it enables it. And that's an important part of this standard. I'd like you to think about this. I'd like you to think that we have, as these sidewalk robotics come in the next few years, it will drive up delivery volume, same day delivery, but it has 2 other effects. It changes and drives up new challenges to congestion. I think it's probably pretty clear we're going to move congestion from road. We could move congestion from road to sidewalk or from car to robot and so forth. It also has knock-on effects with logistics. It influences e-commerce logistics, changes there. It could even influence how warehousing operates. It's highly expected it will operate how warehousing operates. And there's a little side point here. It's very difficult to change supply chains as it is to change cities. So there's a lot going on with these robots and this automation. It's a lot more than went on with scooters, and it's a lot more that went on with ride hailing. It's an order of magnitude more complex, and it has huge value and huge risk. So just be aware of all those things. That's why the standard. Briefly, want to use accessibility by design features. So we want to make sure that the standard addresses all accessibility issues so that the system we end up with, if it works for accessibility issues, it works for everybody. So that's the end of my my presentation. Thank you for that. I hope I haven't run over too much, but I'm going to stop sharing, I think, and take questions if I can.
Perfect, Bern. Your timing is impeccable. We do have a handful of questions. Let's try and get through them. First question, great presentation, Bern. Very insightful as to the current challenges and complexities around Kerb utilization. From a perspective of municipality, what would you see as the first steps a city should be reviewing to either prepare for or consider this whole area of sidewalk as a service in a space? Also, any municipalities or existing cities that have crossed some of those hurdles into bylaws or ordinances to inform learnings?
Well, first of all, I invite that questioner, if they're with a municipality, to join our effort. But I'm going to answer the second part of this question is that I mentioned that San Francisco has taken a look, rejected and returned to them. Washington, D.C. is probably, in North America, I would say Washington, D.C. has done more work than any. Most of the other work has been done in campuses. So that's, I'm afraid that the campus experience, interesting, it's not a municipal experience, it's not enough. So I can introduce that questioner to somebody in Washington, D.C. to get their experience. I think that will be very valuable. But I also invite that person to reach back to us and join the, there's a round table that we organize amongst municipalities to help get their feet into this standard. And that would feed back to those parties a lot of ideas and a lot of information. Very helpful to that questioner.
Yeah, and then the other thing I would add to that, Bern, is that also if you're looking for some help in those first steps, that's one of the things that Harmonize Mobility does. Because we're developing the standards, we do have a lot of deep knowledge, and Bern showed you pieces of the maturity model, which we have. That will be a good way to learn what you need to worry about as a municipality and what you don't need to worry about. And so you can contact us if you want.
Probably need to worry about a lot of things. I'm not sure the list of things you don't need to worry about is very long. There's a lot of it. This touches everything.
Yeah.
It touches most things, put it that way.
Okay, so we're going to move on to the next question. Providing operation rules in a format enabling automated parsing would require a domain-specific language. Is such a language going to be part of the standard?
So we're developing domain-specific data definitions, and we're going to be developing procedures. But a language like a computational language, that's not anticipated. In fact, a standard is a data standard. Like, here's the data, and here's what they mean, and here are the procedures to use this data. The standard does not set a single rule. It does not say how many should be. It just says, if you want to say what they are, here's how to describe that. Here's what the expectation is. It will end up being like you could think about a V2X system, but it's really kind of a fleet to governance system, because what the municipality does is govern these systems by saying, here's how we want to populate the rules. And there needs to be a system to make those populated rules available on demand to a fleet that says, I need to do this or park there or drive there or go there. What's my rules right now? And can I reserve a space? So the answer is the intention is that this wouldn't need a special language, although that might be interesting. If that person knows how to do that, I would like to have that conversation. I hadn't thought about having a special language.
We've got the name, Bern.
Keep it.
All right. So let's move on to the next
I'm going to
question.
be sorry they asked the question.
All right. Do the emerging standards for sidewalks designate various categories of sidewalks? For example, open plazas, residential sidewalks, mixed bike or pedestrian walkways, paved, unpaved, those with stairs or steps, etc.
Only by implication. So the maturity model doesn't say that like a class 3 sidewalk can only be in a residential area. It doesn't say those kinds of things, but you can go into a residential area and assess the sidewalk and say, we really can't allow a class 3 to operate here, whatever the reasons are, because there's various reasons you could or couldn't. So there is I'm just going to use the word a correspondence between type of sidewalk, like residential, business, and so forth, and class of sidewalk, but they're not identical.
Okay. I'll encourage everybody on the call. We still have time for questions. I do have one more question here, Bern, and then we're out. So this question is, why is the discussion around taking space from pedestrians and using the sidewalks instead of using the roads?
That's a very good question. The bicyclists don't want them in their lanes. The pedestrians don't want them on the sidewalk. There's no way you would put some of these small drones on the road. The bigger ones are intended for the road, and that's already a problem. That's why they go 40 kilometers per hour, and they're big, and they have to stay on the road. The case of the large ones, the robot goes to where it's going to go, and the person purchasing whatever's in the robot would come out to the curb and go out to open that vehicle and get what they want. A person that's taking a personal delivery on a sidewalk, even if you allow that bot to go down the bicycle lane, let's say, and when it finally gets to its destination, it has to climb up on the sidewalk and go to the person's door anyway. So at the very least, if you're going to have these small bots, at the very least, they would have to at least cross the pedestrian path. They don't have to occupy it entirely, but they have to at least cross it. That's the contention. As always, the automobile has pushed pedestrians off the roadway onto the sidewalk. The risk is, it's a huge risk. I'm very worried about this risk of now we're going to push the pedestrians aside to make room for robots. If you make the sidewalks wider, I made that point. If we make sidewalks wider and make the clearway better for everybody, robots moving slowly, this could be a win-win, but that's expensive. That's a big infrastructure hit. So that question, that's a key question. That's the key philosophical question.
One of the big questions for sure.
It's tough. And you're not going to brush this aside, but you need to govern it.
Yeah.
And so that first question, what can municipalities do? That's really, need to start thinking now what we're going to do while we prepare ourselves for exploiting safely this technology.
Okay. So I've got another question here, Bern. What prevents the smaller units in particular from being stolen? I like that one.
Yeah, there's a lot of
or being abused or kicked.
Yeah, no, there's been a couple kicked over. There, these kinds of things. Some people say that we've run X thousands of miles of these and no one has hurt us at all. In general, people find them kind of amusing and cute, but I don't think they're going to be amusing and cute when there's a lot of them. You remember the scooters at the very beginning when scooters were lying all over the place, people were throwing scooters in the garbage bin. Can somebody grab one of these and throw it in the garbage bin? Physically, you could do that. There's cameras watching things that would be destruction of property. And so if they're there legally and you did that, then you run a risk of being caught and so forth. Doesn't mean you can't hide your face and do something like that. I think I think they would be subject to more vandalism than somebody on a wheelchair, for example. I mean, sometimes somebody in a wheelchair is harmed intentionally by another human. So it won't be vandalism free, but I think it will be contained.
Yeah. So we're going to go back to the roads and the sidewalks. So picking up from another person's question, are we not presuming that the answer is sharing sidewalk space? And if so, shouldn't we make a standard that is ROW zone agnostic? I assume ROW is right of way.
Right of way. Yeah.
Yeah.
Yeah. No, rights of way are considered in there. When you say rights of way agnostic, it means like does that don't quite understand. So anybody can do anything they want to in the clearway? Is that the implication of that question?
Yeah, it's not clear. Maybe they'll.
The problem is that for the most part, humans ought to have the right of way. I mean, this is a machine carrying a book or a sandwich. Why, and then there's somebody else who's walking to the train station. I think, and most of us would agree, pedestrian ought to get the right of way. There are cases where the robot might not get the right of way. If it's an enforcement robot, it's part of the fire department and it's on its way to a fire. I'm just saying, if something like that were to occur, maybe there's a case for a robot having the right of way. But I think that for the most part, they ought to decline the right of way. And then here's the problem: they get trapped. If a robot has to give the right of way to all people all the time, and it's in a busy area, it could just get trapped off to the side and it can't go anywhere because of the people there. And that was brought up in a conversation with Bosch this morning. Robots are very easily trapped. So the right of way thing is a tough problem.
Okay. Here's another question for you, Bern. What ultimately is driving this technology forward when there are so many barriers for both manufacturers and operators of bots and municipalities and pedestrians? Is the current delivery protocol so flawed?
Well, the current delivery protocol is overwhelmed. I first started working 15 years ago with what are called step vans, those big UPS vans and the big FedEx van. You saw a picture of the FedEx van. Those vans, here in Toronto, I'm in Toronto, here in Toronto, many areas downtown don't have a place for them. They pull over, they double park, they block traffic, they block bicycle lanes and so forth. And it's an unresolved problem. And interestingly, and this is really kind of sad, is that the police department earns income from those vehicles. And the solution, there is possibly a technical solution that we presented to them, and they didn't want that, and that was stopped by the police department because it would reduce their income. And that's just because we're stovepiped. Correct parking goes to the parking authority. Illegal parking goes to the police department, and they wouldn't get off those two positions to act. What I'm saying is, the solution that we have is constrained by how money is shared. That was the current solution of the step vans. What's happened in the past year is e-commerce has shot up, and it's shot up even more because of COVID. So now the delivery protocols are unworkable in large cities. And it's not just the delivery bots either. It's a bigger problem than that. The building I'm in doesn't even have space to bring in all the packages into the concierge desk. So that's it. And the robots are not going to help that. It's going to make it worse. So I hope that answered that question. But I'm getting questions that have bad answers. You'll notice. It's a tough problem.
A big hill ahead. I just wanted to pop in and just let everyone know we are out of time, so I think we could potentially have people dropping off. If anybody wants to hang back, maybe Bern can answer the few questions that remain. But for those who have to go, as it's 1 o'clock, I just wanted to take an opportunity to thank both Bern and Jerry for taking time today to share insight on this clearly huge issue that their ISO standard is addressing and working towards solutions with municipalities, and very interesting, insightful stuff. And thank you both so very much for your time today.
Very welcome.
Thanks, Jennifer.
So. So we can, if you guys have a few minutes.
Sure.
Is there any more? Yeah, no, I'm good. Is there any more questions?
Any questions?
Yes, there are. So, so I've got the clarification on the right-of-way zone. Right-of-way zone equals complete street. Cross-section zone. Why not make a standard that is universal to all cross-section zones? Travel lane, bike lane, pedestrian space, etc. Maybe they should be operating in disabled travel lanes.
Yeah, I mentioned that in the guide that we're developing. You saw pages from the guide that we're developing, and I mentioned that the guidance for complete streets could, I don't want to say the word easily, could be modified to actually have lanes for automated vehicles. See, by the way, it's not just delivery drones, robots, but there may be, we will have automated wheelchairs, for example, autonomous wheelchairs, where, for instance. So there's a lot of value to consider that, and I think complete streets ought to consider that. But anybody who works in complete streets knows that there's only a small portion of our urban worldwide streets are complete streets, and the ones that I've seen done are very expensive. So we'll talk about the infrastructure thing. So if we have to have that as the infrastructure, that's a big deal. That's a barrier. So I agree that there should be a throughway for wherever it's possible.
Yeah. So I got a couple questions here. When separated bike and pedestrian facilities operate side by side, would the robots be in the bike lane or the sidewalk? For example, when cycle tracks are present. And then I'm going to just add on another question. Will they make noise so that they can be detected by people?
No, there's a few questions. So, so first of all, whether they go on the sidewalk or in a bicycle path, that's going to be up to the municipality.
Yeah.
Standard doesn't say where they should go. The standard says if they're going on the sidewalk, then here's how here's what they have to say about themselves in order to do that. And if they're going to go on the bicycle lane, then what speed do they need to go at? So they may in fact have to travel faster in the bicycle lane than they do on the sidewalk, for instance. What was the second question you asked?
Will they make noise so that they can be detected by people who cannot see them?
Yeah. So mostly they're electric. So on their own, as a mobile vehicle, they would make little noise, especially if they're electric. However, because of warnings of people who may have sight problems or hearing problems, the standard addresses sound and lights. It also addresses other things like hazardous content and vibration and so forth, and brightness, because you don't want to have an automated vehicle that may be making a lot of noise to enter a certain area at a certain time of the day. But just to be noticed, sounds and lights would be there, because if someone cannot hear, then you need to have lights, flashing lights, and so on. But I want you to consider, you're walking down a sidewalk and there's dozens of drones and they're all beeping and they're all flashing lights, and it just becomes a wash of noise. So another difficult problem.
Yep. All right, I've come to the last question. Oh, I thought it was the last question, but one just popped in. So let me try this one. What is happening in places like Asia, where technology like this is somewhat more progressed?
So I know they're working on it, and I don't know enough to say what's going on there. Amazingly, some of them are coming out of Estonia. That's probably not amazing if you understand how far advanced Estonia is compared to many countries. But that's as far east as I've gotten. I know the autonomous taxi in Russia, but I don't know any robots there, only because I haven't researched that.
Yeah. Okay. We're going to ask the last question. We did not solve sidewalk or boulevard width for levels of pedestrian exiting shared mobility curb delivery yet. Should not we develop strategy to redesign curb and boulevard first, particularly when wide travel lane remains underutilized? Automation comes after fixing our current problem.
Yep. Yep. if we automate what we have, we're just going to have a bigger mess. We really, really need to start thinking about it. We need to get ourselves in gear, widening sidewalks, narrowing the through lanes. And, you know, it seems like we're ripe to have, we may be ripe to have that conversation, sadly, because of COVID. It may be, if we are able to make it this time, it was the pandemic that gave us the space to actually really reconsider how we design urban people space, active transportation spaces. Very, very poorly organized, very poorly organized.
Yeah.
I would give Toronto a D- for its active transportation space. It's not the worst city in the world. We have terrible active transportation.
But it's a great question, and some cities are already kind of experimenting with flexible infrastructure at the road and sidewalk, where they're taking the curbs down, and so there is some work being done on the smart cities front. But you're absolutely right. Automating a bad process is going to give you bad automation.
There's something done in Waterloo, something done in London, Ontario, where the street was entirely rethought, and the curbs are I don't know what it's called, blended curb. I don't know the name of it, but it's done in a way that it's very easy to widen and narrow the various spaces and so forth. And that's only 5 blocks long. And I have when I look at the result, I can't even imagine how much that would have cost. You want to turn a city with, I think there's like 7,000 kilometers of streets in Toronto, and at $1 million a kilometer. I mean, just like, it's huge, huge, huge amounts of money to really convert these things. So we have to do it selectively, piece by piece. And what do you have? A technology that works wonderfully in 30 or 40 blocks, but the other 70,000 blocks it doesn't, and so on. So it's going to be a while. It's going to be a long time before we sort this out.
So I don't have any more questions, but I do have a comment that the commenter says, I will give Toronto downtown an F.
Ooh, I'm telling you.
I don't hear anybody disagreeing though.
I only gave it a D- because I've been in cities that are worse.
Yeah. Okay, well, we're down to the bottom of our list of questions, and those people who are still hanging on, thanks for being with us and sticking with us.
Yeah,
And
thank you.
Off to you, Jennifer.
Yeah,
Thanks,
thank you
everybody.
both so much, and thank you again to the folks who hung on. We had almost half of you stay, so I think that just shows Bern and Jerry, you're answering some really interesting questions and some things that people are still trying to wrap their heads around. Is certainly a big topic. So thank you again for your time today. Thank you for hanging back. Thank you for everyone who hung back, and have a great day, everyone.
All right. Thanks,
Thank you.
everybody.
Thanks, everyone.
Thank you, Jennifer. Thanks so much. Take care.
Bye.